students, and welcome back to our brightest topic of the year. Let there be light. And there was light. Light is our brightest topic of the year. And so this week we're going to explore various things about light. If you recall, last week we learned about the electromagnetic spectrum and electromagnetic waves and how visible light, which is what we're going to be focusing on today, visible light that we detect with our eyeballs is only one small portion of the electromagnetic spectrum. So we're going to be looking at light throughout the week this week. And I want you to pay attention to this particular picture here of the sun. It may look familiar. Maybe you have drawn a picture of the sun just like this at some point in your life with a circle and lines coming out from that circle. Maybe you even added some other features to your picture as well that maybe bring back fond memories of your childhood. But regardless of how detailed your picture of the sun may have been, undoubtedly you intuitively understood what we call the ray model of light. The ray model of light suggests that light travels in straight lines that we call rays. If we look at this diagram here, we can see the sun, and we can see these lines that we'll call rays coming out from the sun, striking an object like the earth, and behind the earth, it produces a shadow. Now, shadows are only possible when light is shining. But as soon as light shines on a shadow, well, the shadow disappears. Now, let's talk more about this ray model of light. The fact that light travels in straight lines do enable there to be shadows that form. And whether we're talking about shadows in the universe, in our solar system, or shadows on the wall. Maybe if we have time at the end of this period, we can come up and make some shadow puppets on the wall, or you could do it at home yourself for some extra bonus points for a home activity. Maybe take some pictures of some shadow puppets and send them my way. That would be cool. But shadows are possible because of this ray model of light where light travels in straight lines. It also enables us to think of light. And if you remember yesterday, we talked briefly about how light, visible light, functions both as a particle and a wave. So I want you to keep that in the back of your mind throughout the week. But for today, we're going to be thinking about light as a particle. And in that sense, I want you to think about a ball. Here I have, oh, wow, this tennis ball is like nearly invisible on the screen. So let me choose a different ball. Here's a golf ball here. And this golf ball, just like the tennis ball, is able to bounce up and down when you hit it on a flat surface. And whether that flat surface might be the backboard of a basketball hoop when you're making free throws, or whether that flat surface is the floor and you're playing basketball and you're bouncing the ball, balls bounce off of surfaces. And we, I think, have a pretty good intuitive understanding of how balls can bounce. Now, I want you to think about that in the context of light, because light can also bounce off surfaces. And when light does it, we call it reflection. The reflection of light is light bouncing off a surface. Just like in this picture, we see a ball bouncing off of a surface, and we could actually measure the angle of incidence and the angle of reflection of balls. In fact, how this is how world class basketball players know how to get shots every time they throw the ball, because they need to throw it at a certain angle which bounces off the backboard and into the basket. And they may not calculate the angles, but they know the angles when they throw the ball. But we can do that with light. And light bounces off of surfaces, but it does so differently with different kinds of surfaces. There are two types of reflection, and we're going to be talking about these two types of reflection for the remainder of our period today. The first one is called regular reflection. Regular reflection describes the reflection of light off a smooth surface, such as a mirror. And I have a mirror here, and I just dropped my golf ball. Here it is again. Just fell off the floor, fell off the table onto the floor. And when my golf ball fell onto the floor, it fell down and it bounced up, went down and up at a certain angle as it went across the floor. Light does the same thing. Here, I'm going to show you my keyboard. See my keyboard on the computer that I am recording this on. You can see that because a mirror, oh boy, there's a scary image. You can see two of me now because the light is bouncing off my face into the mirror and back to the camera. So here we see an example of what we call regular reflection. Regular reflection is what takes place off a smooth surface. Now, in nature, this can happen probably not on a polished mirror like this one, but it can happen on the smooth surface of water, perhaps, that isn't being blown by the wind. The smooth, perfect surface of a lake or a pond can provide the opportunity for regular reflection in nature. It's what gives us those beautiful reflective scenes of whether they be clouds or mountains in the background off of a smooth surface. So, this is the first type of reflection. And we're going to come back to regular reflection in just a little while. But I want to tell you about the second type of reflection first. And that is what is called diffuse reflection. Diffuse reflection is a lot more common in nature because there are a lot more irregular surfaces. So, diffuse reflection is the reflection of light off of an irregular surface. Now, in the laboratory or at home, you could take a piece of aluminum foil and crumple it up and notice how light does reflect from it, but you can't see your image. You can't see your face in a crumpled up ball of aluminum foil because the light, when it reflects or bounces off a surface, does so at many, many different angles. And so you're not seeing an individual image. On this diagram, the yellow lines illustrate the incoming light rays, the ray model. They're all coming in parallel to one another. But as they hit this irregular surface, the blue lines illustrate the reflected light, and it's going in all different directions. So, yeah, these surfaces can be shiny, but they're not going to show you an actual image. Where do we see this in nature? Well, on water once again, but when the wind is blowing or if it's a stormy day, there's choppiness because the surface of the water is not perfectly flat. So as light shines on it, in these uniform parallel lines, as it is reflected, it's reflected in many different directions. Here's another great example of diffuse reflection. Even though the water is somewhat still, there's ripples in it here, you can see. And so you're not seeing a perfect reflection of the surface of the water. You're seeing diffuse reflection of light waves on the bottom of this bridge. In either case, light is being reflected or bounced from one place to another. Okay, moving right along. Let's get back to regular reflection and some objects, tools, and devices that we are going to be using at the end of this lesson. Mirrors. I already showed you an example of a mirror looking at two of me because you're looking at my reflection. A mirror can be defined as a smooth surface that reflects light. You probably all have at least one mirror in your room. Maybe some of you have even looked at that mirror and said, "Mirror, mirror on the wall, who's the fairest one of all?" Maybe you haven't said it like that. Hopefully not. But I'm sure you've all seen mirrors at home. But not all mirrors are the same. In fact, scientists, we like to group and classify things, as you know. And so we're going to be talking about three types of mirrors. The first type of mirror we see an example of here with the cute little baby looking at its own reflection and saying, "Who's cute? You are. Yeah." Another type of mirror we can see in these bottom two examples where the smooth surface is curved inward and where the smooth surface is curved outward. Both of those give different types of reflection. So let's focus on the first one, plane mirrors. These are the ones that you are probably most familiar with. The plane mirrors are a smooth, flat surface. We've already made reference to these. I've already shown you one of these. You're going to be playing around with one of these, the plane mirror. What I want you to focus on here is that with a plane mirror, what's called the angle of incidence, or the direction of the incoming light ray, you can actually measure with a protractor that angle. That angle of incidence is equal to the angle of reflection. Again, it's this principle that might enable an athlete that uses balls in their particular sport, like basketballs, bouncing off of a backboard. The intuitive understanding of this angle of incidence equals the angle of reflection is important for athletes to know. In light, it's also important for us to know. You can make cool devices like periscopes by knowing the angle of incidence and being able to move mirrors and design instruments to do various things. So the first type of mirror, plane mirror. The second type of mirror is called a concave mirror. Some of you may have seen concave mirrors. Some of you may have concave mirrors in your own homes. Concave mirrors are those that enable you to see your reflection magnified. If you have a mirror like this one here, whoa, you can see that oh my goodness, look at my nose. My nose is looking a lot bigger with this mirror than it did with the plane mirror. How about my eyeball? Look at my eyeball. Whoa. This mirror is curved inward. Mirrors that you might have at home, like makeup mirrors, are concave mirrors. Concave mirrors, and you'll be playing around with one of these yourself. Let's see if it works on the lens here. All right, here's the lens. Woo! Here's the screen. The screen looks much bigger here. as I move it around. You'll be able to play around with these concave mirrors in just a little while. Well, let's look at the cross section. A concave mirror is one that is smooth, like all mirrors are, but it's curved inward. And because it's curved inward, and the blue line here shows the cross section of the mirror, it's curved inward so that the incoming light, and make sure you label your diagram, these light rays that are coming in parallel to one another in straight lines called rays, when they hit the mirror, they are reflected or bounced back to a focal point. That focal point is where all of the light rays converge to a single point. And if you extend your view beyond that focal point, then you are looking at a magnified image of yourself, and something funky happens. I don't want to tell you what it is. Your home activity deals with it, and your observations of yourself in a concave mirror is also going to demonstrate what happens when you look into a concave mirror. And don't worry, you'll have time to play around with this in just a little while. But before you do, I want to introduce the third and the final type of mirror. This is called a convex mirror. A convex mirror is one that is smooth and curved outward. Again, the blue line here represents the cross section of the mirror. The yellow lines represent the parallel rays of light hitting the mirror, and the red lines show how the light is reflected outward from the center. So the mirror is curved outward and the reflection is outward. If you look at this picture here, you can see a great example of a convex mirror that you probably see every day on your school bus. You may also see examples of convex mirrors in stores. Small stores like pharmacies, for instance, are famous for having convex mirrors. Why? Because the view as seen through a convex mirror enables you to see a wide area, not just a small point, but a wide area. When you look at the difference between the reflection of light in a plane mirror compared to a concave mirror compared to a convex mirror, there are quite a few differences here between the three. And boy, I am having just a heck of a time here trying to get through this video today, between people coming in the room and problems with the computer. Let me just get back to the slide here, and we'll finish off with the last slide so that we can end this video for the day before the whole computer goes kaflooey. So we're going to end with this picture of a funhouse mirror. This funhouse mirror is illustrating a combination of all three types of mirrors in one: plane mirror, convex mirror, concave mirror. And when you stand in front of a funhouse mirror, it makes you look very funny because the light is reflected or bounced off of a smooth surface, but it's reflecting at all different angles, which enables you to look really tall, really short, really robust. It distorts your image in so many interesting ways, and it's just fun to look at. So speaking of fun, we're going to spend some time now in class playing around with the three different types of mirrors, and we're going to do some funky activities with them for the remainder of our time together today. Phew. So until next time, I'm going to say bye-bye.